your conscious experience, the vivid tapestry of thoughts, emotions, and perceptions, is one of the greatest mysteries of existence. Despite humanity's remarkable strides in science, technology, and medicine, consciousness remains a riddle that has confounded even the sharpest minds. It's the one question science still can't answer. How does matter become mind? From the moment you wake up in the morning to the time you close your eyes at night, your brain hums with activity. Neurons fire, chemicals flow, and electrical signals traverse intricate pathways. Yet beyond the mechanics lies the real enigma. How do these physical processes give rise to your unique experience of being you? This is the crux of what philosophers and scientists call the hard problem of consciousness. The hard problem was first coined by philosopher David Chalmers to highlight a fundamental question. Why does brain activity produce a subjective inner world at all? Science has given us remarkable insights into how the brain works. We know which areas light up when you feel joy or fear, and we can measure brain waves to understand sleep or focus. But none of this explains the leap from physical matter to conscious experience. It's as though something is missing from the equation, a missing ingredient that goes beyond neurons and brain chemistry, revealing the true mystery of you. Some argue that consciousness is merely an illusion created by the brain, a byproduct of evolution with no deeper significance. But this idea falls short for many, including some of the greatest thinkers in science and philosophy. They believe that consciousness isn't just a side effect of biology, it's something much more fundamental. Could it be that the mind isn't merely a product of the brain but is intertwined with the very fabric of the universe itself? This brings us to a revolutionary idea, the quantum connection. Traditional neuroscience views the brain as a biological machine, processing information in predictable ways. But what if this view is too limited? What if the key to understanding consciousness lies in an entirely different realm of reality, the quantum realm? This is where the mystery deepens. In the coming sections, we'll uncover how the strangeness of quantum mechanics might hold the answers that neuroscience alone cannot provide. Because the question isn't just how the brain creates consciousness, it's whether consciousness in some way shapes the universe itself. What lies beyond neurons and brain chemistry could be the key to understanding the profound mystery of who and what you truly are. To understand where science might find the missing piece of the consciousness puzzle, we need to step into the quantum realm, a world so strange and counterintuitive that it makes science fiction look ordinary. It's a place where particles can exist in multiple states at once, teleport across space, and even pass through solid barriers as though the rules of the macroscopic world simply don't apply. At the heart of this realm is quantum superposition, a phenomenon where particles can exist in multiple states simultaneously. Imagine flipping a coin and having it land as both heads and tails at the same time. This is the bizarre reality of particles in the quantum world. Then there's quantum entanglement, often referred to as spooky action at a distance. When two particles become entangled, their states are linked no matter how far apart they are. A change in one instantly affects the other, as though they're communicating across space faster than the speed of light. This isn't just theoretical physics. These phenomena have been observed and measured repeatedly, and they defy the classical understanding of reality. But here's where it gets even more fascinating. The quantum world doesn't stay confined to the microscopic. Its effects ripple into the macroscopic world, influencing everything from the chemistry of life to the mechanics of the cosmos. Take quantum tunneling, for example. It's the process by which particles tunnel through energy barriers they shouldn't be able to cross. Without it, the nuclear reactions that power the sun wouldn't occur, and life as we know it wouldn't exist. Quantum mechanics, in essence, orchestrates the fundamental processes that sustain reality itself. So how does all of this tie into consciousness? Some researchers believe the brain operates like a biological computer, crunching data and producing thoughts. But others suggest that this analogy is incomplete. They argue that consciousness can't be reduced to algorithms or circuits because it's tied to something far more profound: quantum processes happening within the brain. This idea might sound like a leap, but the quantum world already operates at the edges of what we understand. Could consciousness itself emerge from the strange, probabilistic dance of quantum particles? Could the key to the hard problem of consciousness lie in phenomena like superposition and entanglement, where information exists in a realm beyond the limits of classical physics? The implications are staggering. If consciousness is connected to the quantum fabric of reality, it suggests that your thoughts, emotions, and sense of self aren't just fleeting products of biology. They're intricately linked to the fundamental structure of the universe. In the next part, we'll explore a groundbreaking theory that dares to bridge this gap. Developed by a Nobel laureate and an anesthesiologist, it proposes that the quantum mysteries we've just discussed are happening not in the vastness of space, but inside the very cells of your brain. Stay tuned to uncover the revolutionary model that might finally explain how the quantum world gives rise to the conscious experience. For decades, scientists have tried to explain consciousness through conventional neuroscience. But two unlikely collaborators, Sir Roger Penrose, a Nobel Prize-winning physicist, and Dr. Stuart Hameroff, an anesthesiologist, proposed a groundbreaking theory that steps far outside traditional boundaries. They called it orchestrated objective reduction, or orchestra, and it's nothing short of revolutionary. At the core of their theory lies a stunning idea. Consciousness emerges not from neurons alone, but from quantum processes occurring deep within the brain's cells. Specifically, these processes happen in structures called microtubules. Microtubules are tiny, cylindrical proteins that form part of the cell skeleton, providing structural support. But Penrose and Hameroff believe they're doing much more than that. They're functioning as quantum processors. The orchestra or model suggests that inside these microtubules, quantum states are constantly being created, maintained, and collapsed. In other words, microtubules are acting as the brain's quantum computers, processing information in ways that classical physics cannot explain. This idea directly challenges the traditional view that the brain operates purely on electrical signals and biochemical reactions. But what makes this theory so compelling is its potential to solve the hard problem of consciousness. According to Penrose and Hameroff, the quantum states in microtubules are influenced by the very fabric of the universe, what physicists call quantum gravity. In this view, consciousness isn't just a byproduct of brain activity. It's connected to the fundamental structure of spacetime itself. Here's where the theory takes an even bolder turn. When a quantum state collapses inside a microtubule, it generates a moment of conscious awareness. This collapse, known as objective reduction, is what gives rise to your thoughts, feelings, and perceptions. Essentially, every conscious moment you experience is the result of a quantum process happening at an unimaginably small scale inside your brain. Skeptical? You're not alone. Critics argue that the brain is too warm and wet for delicate quantum processes to occur. Quantum states are notoriously fragile, and the chaotic environment of a living brain seems like an unlikely place for them to persist. But Penrose and Hameroff counter this by pointing to evidence that quantum coherence can exist in biological systems. For example, photosynthesis, a process vital to life, relies on quantum mechanics to efficiently transfer energy. If plants can harness quantum effects, why not the human brain? The implications of this theory are mind-boggling. If microtubules truly function as quantum processors, it means your conscious experience isn't confined to the physical limits of your brain. Instead, it's intertwined with the quantum fabric of the universe. This raises profound questions. Is your mind localized, or is it connected to something far greater? Could consciousness extend beyond the individual, hinting at a deeper unity underlying all existence? What's most exciting is how the orchestra or model redefines the relationship between mind and matter. Instead of viewing the brain as a closed system, this theory suggests it's an open conduit, interacting with the quantum field in ways we're only beginning to comprehend. It bridges the gap between the microscopic dance of quantum particles and the subjective experience of being alive. As we continue, we'll examine the challenges this theory faces and explore the staggering possibilities it opens up. From redefining human potential to reshaping our understanding of the universe, the Penrose-Hameroff theory could be the key to unlocking new frontiers in consciousness research. The Penrose-Hameroff theory has sparked both excitement and controversy in the world of consciousness research. If their model holds true, it could be the breakthrough that scientists and philosophers have been searching for to finally explain consciousness. But with any groundbreaking theory comes a series of challenges and criticisms that must be addressed. One major criticism centers around the practicality of quantum processes occurring in the brain. As we discussed earlier, quantum states are delicate and easily disrupted by heat and noise. The brain, however, is a warm, dynamic organ, filled with electrical activity and constant biochemical interaction. Many skeptics argue that the brain's environment is too noisy for quantum coherence to persist long enough to have any significant effect on consciousness. However, proponents of the theory point to increasing evidence that quantum phenomena can occur in biological systems. For example, the process of quantum tunneling plays a crucial role in enzyme reactions, and certain birds navigate using quantum entanglement. If such processes are possible in the natural world, why not inside our own brains? The debate is far from settled, but one thing is clear. The Penrose-Hameroff theory is challenging the boundaries of what we understand about the brain, consciousness, and quantum physics. The implications of this theory extend far beyond the laboratory. If consciousness truly arises from quantum processes in the brain, it could radically alter our understanding of human potential. Imagine a future where we can directly manipulate quantum states in the brain to enhance cognitive abilities, heal mental illnesses, or even expand our consciousness beyond the limits of the individual mind. We're already beginning to see the first steps toward this future. Advancements in quantum computing and neuroscience are moving in parallel, with researchers exploring how quantum mechanics might be harnessed to improve brain function. Some believe that, in the coming decades, we may even be able to engineer consciousness itself, tapping into the very quantum fabric that governs reality. This brings us to another profound question. If consciousness is indeed a quantum process, can it be manipulated, engineered, or even replicated? Could we one day create artificial consciousness, or even transfer human consciousness to a machine? While these ideas sound like science fiction, they are now being seriously considered by both physicists and neuroscientists. The boundary between mind and machine is becoming increasingly blurred, and the possibilities seem limitless. But with these exciting prospects comes an ethical dilemma. If we unlock the power to manipulate consciousness, what consequences could arise? Could we alter the very nature of what it means to be human? Could we reshape our identity, our free will, or our sense of self? As we push the boundaries of consciousness research, we must also confront the responsibility that comes with it. As for the future of this theory, we are still in the early stages. While the orchestra or model provides a compelling framework, it lacks the definitive evidence needed to confirm it beyond doubt. Researchers are actively looking for ways to test the theory through experiments that could prove or disprove the existence of quantum processes in the brain. If such evidence is found, it could trigger a revolution in how we understand the mind and the universe itself. But even without conclusive proof, the Penrose-Hameroff theory has already reshaped the conversation about consciousness. It has brought quantum mechanics and neuroscience into the same conversation, pushing both fields to explore the deep, interconnected nature of reality. Whether or not it turns out to be the definitive explanation, the theory has opened the door to a new era of exploration into the nature of consciousness. In the coming decades, we could see a new wave of research that redefines what it means to be alive, to be conscious, and to exist. The potential for understanding the mind, the universe, and our place within it has never been greater. And as we continue to uncover the mysteries of quantum consciousness, we may be on the brink of discovering something even more profound, an understanding that could redefine not just science, but humanity itself. As we draw to a close, it's clear that the connection between consciousness and quantum mechanics is a topic that holds the potential to completely transform our understanding of reality. The theory proposed by Penrose and Hameroff, though still in its infancy, offers a tantalizing glimpse into how the most profound aspects of human existence might be linked to the very structure of the universe itself. When consciousness meets quantum mechanics, everything we know about the mind and the cosmos begins to shift. If the orchestra or model proves to be correct, it would suggest that consciousness is not just a byproduct of brain activity, but a fundamental feature of the universe, woven into the very fabric of spacetime. In this view, your thoughts, experiences, and awareness are deeply connected to the quantum processes that govern everything from subatomic particles to the entire cosmos. This revelation could have far-reaching implications not only for science but for how we perceive ourselves. It opens up the possibility that consciousness is far more than an isolated, individual experience. Instead, it may be part of a greater, universal network, an interconnected web of awareness that stretches across time and space. If we begin to understand and harness these quantum processes, we might unlock capabilities we've only begun to imagine. Expanded consciousness, enhanced mental abilities, and a deeper connection to the universe. But with this immense potential comes an equally great responsibility. The possibility of manipulating consciousness, whether for personal enhancement or through artificial means, presents ethical dilemmas that we must carefully consider. What happens when we begin to alter the very nature of human experience? Could we change the essence of what it means to be conscious, to be human? As we push the boundaries of scientific discovery, we must also grapple with the consequences of our actions. Looking ahead, the future of consciousness research is both exhilarating and uncertain. With new advances in quantum computing, neuroscience, and experimental physics, we are on the cusp of a new era. The search for evidence of quantum processes in the brain could unlock answers to the greatest mysteries of existence. And if the orchestra or model holds up under scrutiny, it could revolutionize not just our understanding of the mind, but our place in the cosmos. As the boundaries between mind, matter, and the quantum fabric of reality blur, we may discover that consciousness is nature's greatest quantum computer, an intricate, dynamic system capable of tapping into the very forces that shape the universe. The implications for science, philosophy, and even spirituality are profound, challenging everything we thought we knew about what it means to exist. So, as we conclude, remember this: the theory that connects mind to the fabric of spacetime is not just an intellectual curiosity. It's a revolution in how we understand life itself. It's a theory that bridges the gap between the known and the unknown, between mind and matter, between the individual and the cosmos. And as we continue to explore the mysteries of quantum consciousness, we may be stepping closer to understanding the deepest truths of our existence. This is just the beginning. The journey to understand consciousness, reality, and the quantum mind is unfolding before us. And as it does, we may discover that we are not mere observers of the universe, but active participants in shaping the very fabric of existence.